everyone! Magandang umaga. Ohayo gozaimasu. Zhao sheng hao. Chou nachim. Sawadee ton chao. Bonjour. Buenos dias. And to everyone who's watching this, good morning to all of you. This is your host Shira and Andy of Medisingaling, wherein we talk about your worries and queries about anything concerning health.
Alongside the resident doctors who are two of the most outstanding doctors in their fields, Dr. Campbell and Dr. Sunshine. We will be discussing each and every one of your health concerns and hopefully give meaningful advice to everyone.
If you have missed our previous videos, you can just visit Medisingaling's official YouTube channel. And if you're not subscribed yet, you might as well press that subscribe button and hit the bell icon so that you will not miss any of our future uploads.
Good morning, everyone. This is your host Andy alongside my partner Shara. We'll be hosting our weekly Medisingaling YouTube live stream, wherein your health is our number one priority. Without any further ado, let me introduce you to our resident doctors, Dr. Campbell and Dr. Sunshine.
Good morning, Shara, Andy, and most importantly, to all of our viewers. I hope you're having a good day.
A pleasant morning to everyone here in our weekly YouTube live stream.
Now that we're all set, why don't we introduce our special visitors for today? Let us all welcome our celebrity guest, Mrs. Jenny Aquino and the stunning Mr. Jayron Malikaya, who are known for their renowned acting prowess on the award-winning movie, I Want to Eat Your Hypothalamus.
Oh, hi Shira! Hi Andy! And can I give a shout out to my husband? It would be very quick. Shout out to my very, very, very handsome husband. I'll be home soon, just wait for me, ha?
Hello, Miss Andy, and to you, Mrs. Shearer. Oh, Miss Shearer, can you please be my wife? Oh, my bad. Good morning to everyone.
Now that we're done with the pleasantries, shall we proceed to our main event of this gathering, partner?
It's already July, but it seems like these two are still in the month of February. Anyways, our main topic for the day, partner, is about feedback mechanism. But what intonation is feedback mechanism really is, Dr. Sunshine?
Well, before we look into the meaning of feedback mechanism, we must first think about the word homeostasis, since these two are inseparable. Actually, the term homeostasis was first coined by the Harvard physiologist Walter Bradford Cannon in 1926. According to him, homeostasis is a self-regulating process whereby biological systems maintain stability in order to function at an optimal level while adjusting to changing conditions.
If so, what is the correlation between homeostasis and feedback mechanism?
Well, Andy, feedback mechanism is a physiological loop that either returns the body to a normal internal state or what we call the homeostasis, or less commonly, brings an internal system further away from its balanced state.
Doc, I have a special question. It's from my daughter who is currently watching right now. She is an aspiring physiology student and was asking my husband to ask me to ask you, since you have mentioned that feedback mechanism can either return the body to its balanced state or bring it further away from homeostasis. Is there any way to differentiate the two?
Now that is a very good question. You see, there are two mechanisms that exist, namely the positive and negative feedback mechanism. These two act via nerve pathway or chemicals such as hormones to cause a stimulatory or inhibitory effect. But before we differentiate the two, let me invite a friend of mine who is going to show you three components these two feedback systems require before adjusting to any physiological pathways.
Thank you, Dr. Campbell. As they mentioned before, both positive and negative feedback systems require three components to adjust a specific physiological pathway. The first one is the receptor, which is also called the sensor. It receives information about any changes or stimulus anywhere in the body and initiates the body's homeostatic response by sending a message to the control center. Then the control center, or what we also call the evaluator, processes and monitors the message sent by the receptor a while ago and will then proceed to stimulate the effector. And lastly, the effector will carry out a stimulatory or an inhibitory effect according to the control center's instructions. So take this for example. You decided to take a stroll at the park on a hot, sunny day. Eventually, you'll feel kind of hot and uncomfortable, right? So your thermoreceptors will detect this temperature change happening in your body and will send this message to your hypothalamus, who will then notice it. Your hypothalamus will then counterattack this by sending a command to your sweat glands to produce sweat, which will then cool down your body. As you can see, the sensor in this scenario is the thermoreceptor, since it detects that something is wrong with your body temperature. And we all know that the normal body temperature for a human being to work properly is 37 degrees Celsius or 98.6 in Fahrenheit. It then proceeds to send a message to the hypothalamus, which is the control center in this scenario, informing that the body is not in its homeostatic state. In order to return the body to its balanced state or the homeostatic state, the hypothalamus will signal the sweat glands, which are the effector in this scenario, to produce sweat. This will lead to the cooling down of the body in order to return to the normal state.
The body regulates its temperature continuously. It may decrease or increase its temperature according to the situation. But how does it determine the optimum temperature for the body to maintain its homeostasis?
That is a wonderful observation. The system that controls body temperature is called a closed-loop system. As I mentioned before, there are three components that we need to consider: the receptor or the sensor, control center, and effector. However, in a closed-loop system like this one, there is another variable we need to consider, which is the comparator. This additional structure continuously measures the effector output and communicates this information directly to the receptor units. In this case, the comparator is located in the hypothalamus. This tiny region is the one dictating what the normal body temperature should be.
So kapag yung katawan nakadama siya ng lamig, yung comparator magpapadala siya ng signal doon sa preoptic area o yung anterior hypothalamus na magreresulta sa panginginig, pagtaas ng thyroid hormone output, pagtaas ng activity ng sympathetic nervous system, pagtayo ng balahibo o piloerection, pati yung pagconstrict ng mga blood vessels or vasoconstriction para di mabawasan yung heat loss sa ating katawan. Okay, amazing!
Additionally, yung comparator kaya rin niya mag-send na signal doon naman sa heat loss mechanism na nasa posterior hypothalamus na magre-resulta sa pagbaba naman ng thyroid hormone output, pagpapawis. Pati na rin yung pag-widen ng mga blood vessels or what we call vasodilation. Din pala yung dahilan kung bakit namumula yung mga tao kapag mainit yung panahon.
Then, the output of these mechanisms will end either as a net increase or net decrease in body temperature. The body temperature is sensed by the thermoreceptors in the brain and peripherally in the body. And the value is sent to the comparator where it is compared to the set point.
On the contrary, an open-loop feedback mechanism is simpler than the closed-loop mechanism as it only involves receptor, control center, and the effector.
So, if the value is less than the set point, then signals go mainly to the heat gain mechanisms. If it is greater than the set point, then they go mainly to the heat loss mechanisms. In this way, body temperature is constantly sensed and maintained constant or in a state of homeostasis. How marvelous!
I appreciate that wonderful explanation. Now let's go back to the question at hand. Earlier, Mrs. Jenna Aquino's daughter mentioned how to differentiate whether the body is returning from its homeostatic state or further away from it. Kung nakinig kayo sa explanation ni Miss Marian kanina, makikita niyo na yung body bumalik siya doon sa kanyang homeostatic state. This type of feedback loop is what we call a negative feedback mechanism. This type of feedback mechanism is the most common since it is trying to return the body to its normal state, unlike its counterpart, which is the positive feedback mechanism.
Tama ka dyan, partner. Sa positive feedback mechanism naman, kaysa ibalik sa katawan ng kanyang homeostasis, mas lalo niyang i-amplify ang isang physiological system na wala sa kanyang homeostatic range. Examples of positive feedback mechanism are few in numbers than the negative feedback loop, as it aggravates a certain disturbance in the homeostatic state of the body. We can consider it as lethal in nature. After all, having your body outside its balanced state is detrimental for your health.
Then Doc, pwede niyo po ba kami bigyan ng mas positive example ng positive feedback mechanism?
A good example of this is labor contractions, especially in childbirth. You see, when a woman is about to give birth, the uterus must contract in order to push the baby on the cervix into the birth canal. The receptor on this scenario are the sensory cells in the womb and birth canal. Once they detect that the mother is about to give birth, they will send a message to the control center, which is the pituitary gland, to release a hormone called oxytocin as a chemical messenger, which will then mandate the uterus, which is the effector, to contract more.
That is a good example of a positive feedback loop. But curious lang ako, Doc. Can you give us an example of a more negative, positive feedback loop?
A good example of this, but not necessarily good, would be the cytokine storm. COVID-19 is known to have this excessive inflammatory effect in humans, as it not only attacks infected cells, but also those who are normal. Excessive production of cytokine as an inflammatory response to the virus may lead to multiple organ failure or worse, death. The progressive increase in inflammatory effects that brings the body further away from its homeostatic effect makes this a positive feedback mechanism.
Before we conclude our gathering, do you have any advice or any last remark regarding our topic for this morning?
We can conclude that feedback mechanism plays an integral part in our everyday survivability. The world is changing at an alarming pace, but our body is trying to cope and maintain its stability in order to live normally in this mortal plane. The best thing we could do in order for this wonderful system to function properly is by taking care of ourselves. For once this system becomes corrupted or fails to function the same way it did before, our lives will be at stake.
Well, now that our YouTube weekly live stream came to an end, I just want to invite everyone to subscribe to our YouTube channel, Medisingaling, for any updates and other interesting videos concerning health. And if you want to learn more about the other examples of feedback mechanism, you can check our official channel below. Thank you very much for watching.